Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem was suggested by one of our readers. So it's a very similar problem to the previous ones that we discussed when two cars are moving towards each other and they move with a constant speed. But this is a little bit different. It's basically the same A, the same B. This car moves with the speed v1, constant speed, but this one moves with acceleration, constant acceleration. So it starts with v0 equals 0, but it goes in this direction with acceleration a. And the question is, of course, when and where do they meet? So, three methods, like in the previous. Let's go with the first method. The first car travels the distance before they meet d1, and the second car travels the distance d2. And of course, d1 equals v1t, and d2, it's the formula for body moving with initial speed 0, so 0 by t is gone, and so it is at squared 2. And of course, total distance d is given to us. D is equal v1t plus at squared divided into 2. So it's very simple, multiply by 2, 2d equal 2v1t plus at squared. Move all to one part to the left, and then start writing with the left part first. At squared plus 2v1t, and I move 2d here, so minus 2d equals 0. So a is known, v1 is known, d is known, t is an unknown. T is unknown. So one equation, one unknown, square equation. So it's very simple. T and square equation always have 2 times. So we will have 2 times here. Oh, interesting. T12 equals minus 2v1 plus minus square root. And this would be tv1 squared would be 4v1 squared minus, this minus now will be plus, so 4da, so 4a multiplied by 2d, and we have to divide this into 2a. Okay, Kobe, we are filming here, Kobe. We are filming. Yeah. So basically this is a solution. We have to figure out also why it's minus plus. If it's both minuses, it will be some negative time. It's kind of weird, but we will discuss this later. Of course, it only has to be plus. And this square root obviously is bigger than this 2v1 because this plus something extra. So we can write it's here, t1 equals minus 2v1 divided into 2a plus, and I can take out the square root of 4 would be 2, this and this would be v1 squared, and this would be plus 2ad, and this is the formula. And if you want, I can put the numbers right away here and then continue with 2 other methods if you want, but basically let's do that. Let's write t1 minus 2 multiplied by 30 plus 2 multiply 30 squared would be 900 plus 2 multiplied by 5 multiplied by distance 2000, and the bottom would be 2 multiplied by 5. T1 would be minus 60 divided into 10 plus 2 square root 2 by 5 would be 10, so it would be 900 plus 10, 20,000. I can use the calculator. You probably will use a calculator, but I will not use a calculator because I can do it without a calculator, and I will receive T1 minus 60 plus minus 900 plus this, it would be, and I will take 10 out, so I can factor 10 out. You can put the numbers, I will not. Would be 9 plus 20 to 100, it would be 209. Divided into 10. Now you can use a calculator, but I know that square root of 209, 14 squared is 196 and 15 squared is 225. So for my goal and purposes, the square root is 14 and a half. So T1 would be minus 60 plus 10 multiplied by 14 and a half. Oh, here I forgot multiplied by 2. So not 10, but 20. 14 and a half divided into 10. 20 multiplied by 14 and a half, it would be roughly 290. 290 minus 60 would be 230. It would be 230 into 10. It would be 23 seconds. 23 seconds, this would be the time that required for them to meet. We can of course double check it. We can double check it here. So we say the first car is moving 30 kilometers an hour multiplied by 20 seconds. It would be roughly 690 meters. So the distance would be 690 meters. And let's check the second car, AT squared. A is 5, T squared is 23 squared, right? Divided into 2, right? So 23 squared, roughly it would be around 600, maybe a little bit less. So it would be 5, let's put 590. 590 divided over 2. 5 multiplied by 500, it would be 20 plus 590. It would be roughly, very roughly, 1,250. You can check with calculators. Then we will add, so 1,250 is this distance is 700, yeah? They probably match pretty well. 700 meters plus this total will be almost 2,000. Of course, if you do a real calculation with a calculator, more precise, you will have the exact result. So this is the first method. And I will wipe it out because we know I don't want to do it in numbers. I will do it always in formulas. So basically, I will wipe this out too, and I will say, okay, Second method is when we sitting in the car and our system of coordinate is this. So the road is moving towards us with the speed v1 plus acceleration, right? So we know that everything is coming to us, so this distance of the second car that it covers before it meets us is d. And of course we know that initial speed not 0 but the speed of the road. So v1t plus at squared divided into 2. So it's exactly the same equation, only first time we received this sum plus this sum, this distance plus this distance, we sum them together and we got d. But in the second case, when we change the system of coordinate, we say, okay, we are stable, we're not moving, everything is moving towards us with the speed v1, and plus the second car is accelerating against the Earth. So we have the same equation, of course it would be the same, and this would be the same, and everything is fantastic. And of course there is a third method, and the third method is most generic, and this is related with drawing graphs and building coordinates, right? So, this is A, this is B, the distance is D, and then this is a graph. The first part of the graph is a line that goes from here to here. This is the first car that moves, and this is x equal v1t. At any particular moment there is x, and this x is v1t, and what is described here analytically as this formula becomes this graph. As for the second car, we have to tell that x equals v0, v0 is 0, so it's gone. And then there is acceleration, and the acceleration is directed this way, so it becomes negative. So, we have to start with x0, and x0 is this. So the formula is x0 plus v0t plus at squared. This is generic formula. And in this case, x equal, instead of x0, it would be this coordinate where this body, second body is located, it's d, plus 0, and acceleration would be negative, so it would be minus at squared divided over 2, right? And so we receive this should be equal to this. So we write v1t equals d minus at squared. That's it. This is our equation. We have v1 known, d known, and a known. We don't know t. And this is exactly the same equation that I just wiped out, but it is like that. And so the graph is parabola, and here do they meet? And this is this times that would be determined because at this time they have exactly the same coordinates, and that's it. And we will have quadratic equation. And we will have the same quadratic equation and the same solution. One other thing I want to talk here, and this is about two solutions. Remember, quadratic equation has two solutions, and we removed the second solution because we're only interested in positive times. But let's discuss why it may be the case. So let me write the time that includes not only positive but negative time. And this is our point D, and we have the formula for this graph. For this graph we have this formula. So this is x equal v1t, this formula and this graph. And for another we have d minus at squared. So we have this parabola. So this graph is this, but this graph would be a parabola, and this parabola will go like this. Alright? So, this would be our first intersection of our straight line, and this would be our this would be our second intersection. So, parabola and straight line are intersecting in 2 points now. And because they intersect in 2 points, there are 2 solutions. And this solution is negative, this solution is positive. This, of course, as described with this formula, was plus. But if you put minus, this would be this time. Negative time. And what this means? That means that if this body would be moving forever, arriving to this point A at this time, and then continuing with the same speed v1 all the time, this would be the graph. If this car will start also somewhere here, it will decelerate, because it will be moving with the same acceleration. Decelerate, 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 stop here. And of course it stopped here because tangent equals 0. There is no slope at this point D, right? So, it stopped here, but acceleration still pushing it this way. So it starts to decelerate and starts to move this way. It continues to decelerate. Sorry, acceleration A is negative, so it's decelerate same way, and this because X is positive in this way, so A is coming with a negative sign. And so when then they meet somewhere here, and this is exactly this point, and that's exactly why there are 2 solutions. 2 roots of quadratic equations. So 3 methods, same results, 23 seconds or whatever, you can find it with your calculator better than I do it in my head without calculator, but something around 23 seconds. Okay, thank you very much for visiting. As always, subscribe, click, like, write a comment. See, this is a problem from my reader who put this problem in the comment, and so I thought that this problem may be interesting for many of you. So, hence it's here. Thank you very much.